At Astra is our mantra. At Astra to the stars. At Astra, it's who we are.
Welcome to Around Space. I'm Kent Miller. Today we're going to be talking about a railroad to the moon and Mars. Railroad is a figure of speech. It's a historical reference to something that happened a century ago when the United States built its first transcontinental railroad, which connected the whole country coast to coast. And this expression, railroad to moon and Mars, came from NASA Administrator Bridenstine when he spoke at the Humans to Mars Summit in April of 2018. I'm delighted to have with us Dr. Ajay Kothari, who has written a paper on this subject. In 1979, he got his PhD in aerospace engineering at the University of Maryland. From 22 to 88, he worked as an assistant research professor at the University of Maryland, and in 88 he branched off into the private sector, founding his own company, Astrox, which does R&D and design for the U.S. Air Force, DARPA, and NASA. Welcome back to this table.
Thank you very much, Kent. Delighted to be here again. And before we start anything, I want to first thank Donnie and David for doing this,
Okay.
for doing this wonderful work, and also everybody here who's also volunteering. So thank you very much.
All right. So tell us the history of this proposal that's come out.
Right. Yeah. So this is really very interesting. I mean, as you mentioned, Jim Bridenstine, Administrator Bridenstine, in April mentioned that, somebody asked a question that, like right now with all the emphasis that you have on the moon and the administration has on the moon, are we going to do anything with Mars, or are we going to, forget about it or something? He says, no. What we are trying to do now is to build actually a sort of a virtual railroad to space, to moon and Mars, and it probably seem like a hyperbolic statement, but actually it was quite interesting, and it was in a sense it was prescient.
Yeah.
And so I sort of picked that up, and I thought that if this is really can be the case, can be done, and it could be like a railroad.
Meaning something that's reliable and routinely scheduled, that operates
Right,
in a routine way.
Routine way, and it would have various different possibilities of, you want to go from here to Philadelphia, from here to this place, from here to another place. So it would be like, that possibilities in space that
Right.
we would have to create.
All of our destinations would be linked up.
Linked up. So I sort of look back, and it's very interesting that there was a guy named Dr. Hartwell Carver.
The proposal for the transcontinental railroad.
Transcontinental. In
Yes.
1832, he wrote an article in New York Courier and Inquirer, and then subsequently in 1847 that is,
Right.
he submitted a proposal for a charter for the railroad to the Pacific Ocean. So actually from 1863 to 69, in 6 years, they built this entire railroad in 3 sections. He proposed that we go from Michigan Lake to Oregon,
Right.
but they went a little bit south, further, and built this in 3 sections from Omaha, Nebraska to all the way to San Francisco, Oakland. In 3 sections, Oakland to Sacramento, Sacramento to
Right.
place.
Now, this
and
got
that,
started
so-
during the U.S. Civil War, so there were some
It was, yeah,
issues there,
63. I mean, amazing.
Yeah, that's
And-
right, right in the middle of the
and then
war.
Right in the middle of the war, they were able to do this in 6 years.
Yeah.
Now, another interesting thing is exactly almost 100 years after that,
Mm-hmm.
what happened in 1963 to 69, we built another railroad to the moon
the Apollo
with
program,
Apollo,
yeah.
Apollo program. And now, coincidentally, I guess, it's exactly 50 years later, half a century later,
Yeah.
2018, and we must build this railroad now for space, so to speak. So it's not, you know, it is prescient, whatever he said. There is obviously a connection here.
Now, we have some policy guidance. We have, the administration has issued
That's right.
what?
Yes. So the Trump administration has issued Space Policy Directive 1, 2, and 3. And 1, of course, obviously is for lunar colonies and all those kinds of things, and 2 and 3 are connected to that, commercialization, etc. 1 is more applicable to what we are talking about here.
Okay.
So we have that. They have also said that we should have, this is interesting, public-private partnership. To me, that obviously public-private partnership means NASA industry partnership. To me, that means pride-profit partnership. Pride through NASA for the public, for everybody. Profit for industry.
Okay,
And then partnership.
so it's not strictly a prestige project.
It's not strictly a prestige project, it's strictly not a profit project.
Okay,
And
that's a
it should
partnership.
be done as a combination. So
Okay.
this is what we have the ability to do now. Principally, what I'm suggesting is this, that what we do, we have this SLS and BFR and all those ideas,
That's the space launch
the
system.
Space Launch System, SLS, and Big Falcon rocket of SpaceX and all those ideas. But I think neither one of them is that necessary to begin with right now.
Right.
What I'm suggesting is we do it this way. We have already flown Falcon 9 Heavy
Right.
recently and successfully. I mean, 2 of the side
So
cores,
this is proven hardware.
proven hardware.
Yeah.
2 of the side cores, as you might have seen, amazing sight to see them land at Cape Canaveral,
Yeah.
both together like
They
that.
come back and land.
And
yeah.
come back and land.
Yeah.
2 within a few seconds of each other, actually. And the middle core, the central core, did not. It sort of crashed. It crashed.
Yeah.
But maybe next time it will not.
That's right. Yeah.
So we have that. Then, about a month ago, Russian Soyuz went to ISS, and they did that on what is called a fast track, which means they have to have a connection docking made to ISS within 2 orbits. Normally, we take like 1 or 2 days before we actually after you take off, after before you dock with ISS or whatever. But this time they did that, and they did it automatically.
Yeah.
So it's possible to do this docking also automatically. So many of these things are sort of synergizing now. So what I'm suggesting is that we use this, the possibility that exists today. And what we do is we use Falcon
Okay.
or New Glenn or whatever rocket. We launch that rocket. The second stage, upper stage, goes into orbit and will stay in orbit. Then 2 days or certain number of days later, another flight is made, and the second flight, second stage, will go and dock with the first
Okay.
second stage.
So what we're talking about is assembly in low Earth orbit.
The assembly in low Earth orbit.
Okay.
Now the
And-
thing is,
and refueling.
and refueling may or may not be necessary.
Okay.
There are both options I've looked at.
Okay.
So what I'm saying is that this is, if, let's say, the Falcon 9 payload to low Earth orbit is 22.8 tons,
Okay.
is what they're saying.
Yeah.
Let's say that I take only 1.14 ton as payload. That means I can take extra propellant there. Now my second flight second stage would contain, with the same design, would be able to contain 22.8 ton extra fuel by the time it gets to, so when they rendezvous, it'll have some fuel left over.
That's right.
I can use that fuel and some previous fuel to do the translunar injection, and then to do the to be captured by the moon and to land on the moon.
I see. So what we're doing is we're assembling in low Earth orbit
Right.
partially fueled upper stages
Right.
to create some kind of a moon to, or Earth to Mars,
Low Earth
or
orbit,
Earth
low Earth orbit to the moon.
to the moon vehicle.
And so I think that this kind of a thing is possible. So
Okay.
what I had to do for doing this is to see if, obviously, we have to find out if there is enough propellant that would be available for doing these kinds of maneuvers. So we had to start with the subway diagram of delta V.
Okay. So each link in this subway diagram, it's a very colorful, beautiful diagram. Each link has a number. It's a little hard to read on the TV screen.
Right.
But these numbers are the delta V requirements for moving from one node to the next on that diagram.
On this, yes.
I see. So you have one branch near the bottom called moon,
Yes.
and you go from low Earth orbit to intercept. That's intercepting with the moon, right?
With the moon, right.
And then you have to circularize into low lunar
Lunar orbit, LLO, right.
and then landing.
And then landing,
All right,
right.
so
yes.
we add up 3 delta V's together.
That's correct.
I see, okay.
Yeah.
And later when we talk about the Mars, you're doing something very similar.
So it's something
Again,
very similar.
You're
right.
adding 3 numbers that result in us on the
correct.
ground.
Right, yes.
On
right,
Mars.
yes, on
Okay.
Mars.
Got
So
it.
there, that particular, those 2 slides that we have here are indication of that. So again, as you can see in this slide, we take off from Earth using Falcon Heavy,
Sure.
and then we have upper stages which dock, combine. How many upper stages for how much payload, etc., is something that I'm going to show you
Okay.
in a minute or 2.
I see.
But the idea is that it is possible to do this. Now, what's the beautiful thing about this is this is available today.
Yes.
So I can do it tomorrow. I can start doing this thing tomorrow. So the first thing that I would do is to do a proof of concept type of a thing with Falcon 9, and I would take maybe a small amount of payload to the lunar surface, and I'm going to talk about that.
Okay.
Now, having done this moon thing, I wanted to find out if I can extend the same railroad idea to Mars also. And I found that yes, I can, and with a reduction in payload, of course, obviously,
Right.
because
The delta V requirement's about 50% greater to
50%
land
greater
on the surface of Mars.
Mars, right?
Okay.
Yeah,
Yep.
than for the moon. So now, so these are the delta V's that we have over here.
Okay.
Now, the next step for us is to be able to convert these delta V's into the amount of propellant that will be required. So now I'm getting a little bit more technical here.
Sure,
So-
that's right.
So,
yeah.
pardon that. But the table here shows, now we can have, obviously, 3 different types of engines for the upper stage. We
Right.
can have an RP LOX engine.
RP is a
which
kind of
RP is the
kerosene.
rocket propellant kerosene type.
Sure, yeah.
And LOX is
Right.
liquid oxygen, of course. We can have that. Or we can have that methane with LOX, liquid, natural gas.
That's right.
LNG with and we can have liquid hydrogen with LOX also. So 3
Right.
different engines are available, and as you can see, they are the Merlin 1D, V or SUP engine or BE4 type engine. So these are all available. So from that, I have built in my code at my Astrox Corporation, I was able to calculate the propellant fraction that these delta V's would mean. 18,602 feet per second is the delta V required for landing on the moon, and 31,397 is the delta V required for landing on Mars.
Okay.
So converted them all to this. So
All right, so
That's how
let's take a
I'm
look at,
doing it.
you have some slides here, the spreadsheets, right?
Yes, right, yes.
Now these spreadsheets basically detail, it's a little hard to read on the TV, but
Right, yes, yeah.
but you've,
yeah.
you've,
But I
you've
have,
worked it out.
I
Yeah.
worked it out, and
So
I have these calculations
what
to
everything
showcase
weighs, how much
right,
propellant.
how much
Yeah.
propellant would be required.
Right.
So let's look at the first one on the upper left, for example.
Yeah.
That is what I would do. This is step one, and this is the proof of concept.
Right. And
So
here
this
you're
is what I
using
would
the
do.
kerosene fuel.
I'm using what's available today
Exactly.
with SpaceX. I already have that. I'll just buy 2 flights from SpaceX, and I can do this tomorrow,
Right.
or 6 months from now, or something like that. I can start this tomorrow, and I would have 2 flights, and both of them would dock.
They would mate.
They would mate,
Okay.
and then both those upper stages would go to the moon.
Okay.
In that case, I would be able to get a propellant fraction of 0.8143, which if I have a payload of 1.14 ton, which is about 2,500 pounds.
Okay.
And so I can do that.
So you can land a little more than a ton of payload, and you have the 2 empty tanks.
Plus
also.
2 empty tanks also. So this is just proof of concept. Now, once I've done that, I move to the next step, which is that I can try to refuel. Now, this is what I would like NASA to work on. Orbital refueling concepts,
Sure.
experience, all those things, and hopefully NASA can develop that technology enough
Okay.
that we can do this. This is something that NASA can do tomorrow by buying these flights.
Okay.
Other possibility is methane as a fuel for the upper stage,
Right.
which is what SpaceX is working on, Raptor and other places. So we can use that also.
Methane's a little less dense, but it has a higher specific impulse.
It has about 10 to 12 seconds higher specific impulse, about half as dense.
Yeah.
RP is 805 kilograms per meter cube, and methane is 423, etc.
But the numbers work.
But the numbers work, exactly.
Good, good.
Now, having done that, what I would do is to move to Falcon Heavy.
Okay.
Now we are talking larger payload possible. And so I would be able to do larger and larger payload all the way up to 40.8 or 51.68 tons.
So over 50 tons you could
Up to
land
50
on.
tons, which is 114,000 pounds.
yeah.
I can land on the moon. Now,
That's enough to start a colony.
that's enough to start a colony, right, yes.
All right.
Right, yeah. And if I use hydrogen, then I get a little bit better. So
Yeah.
now, so these are the steps that I would do. I would do the step 1, step 2, 3, 4 that I mentioned earlier, and then do the additional larger payload sojourns later. You know, maybe that'll come maybe a couple of years afterwards. I can do this first 1 or 2 steps in 1 year,
Sure.
and I can do the other things in 3 years from
Okay.
now. The Falcon
So,
Heavy things.
so basically in 3 stages. First
Right.
moon, then Mars, then the whole solar system. Right?
Yes, right, yes.
Right.
I can do both of those things. But I can do that with, right now I'm talking only about moon so far.
Okay.
I've not talked about Mars yet as a possibility. But we can do this. Now, you look at this, in this table, you look at the number of gross in Leo, which is almost for the last one is, the last slide, bottom left. Gross in Leo in this case is 285 tons.
Okay.
That is about 2.5 times more than what the Space Launch System would be able to put up in low Earth orbit.
Okay.
So by doing nothing and not spending any more money on whatever SLS should continue. That's not the point, because the SLS is, but as far as the cargo is concerned, this is something we can start tomorrow.
Right.
Cargo is required for lunar colonies. And so this is about 2.5 times more efficient that way, and a space launch system cost is about $2 billion.
Okay.
So $2 billion is divide that by this weight, and that makes it, and the cost of the Falcon Heavy is about $500 million for 5 flights, and add another couple of $100 million, and cost per pound there is almost 7 times smaller than
Right.
the SLS.
So we have a big cost advantage
Big
here.
cost advantage.
Yeah.
SLS can be used for human transport, and this can be used for cargo,
Okay.
which we will need.
So these empty tanks that we land on the moon
And
can
the
be
empty
used
tanks will be
as-
landing on the moon, and we can put them, first we'll put them on the surface and cover them, we can
Right.
cover them with regolith there, or we can put them, there are lava tubes in the moon, on the moon.
Right.
And you can
But
put them in the
we
lava
do
tube,
cover them
etc.
for thermal reasons and
Thermal
and other
reasons and radiation reasons
And
both.
radiation reasons,
Right,
yes.
yeah.
That's right.
So we can
Okay,
do that.
Good.
Now,
And we even have a Bigelow habitat.
we have
Good.
Bigelow habitat also.
So-
So now what I have is Mars. I want to talk about a little bit about Mars.
Yes.
So
Everyone's favorite planet.
everyone's favorite planet. So I was wondering whether we can do the same thing with Mars also.
Yeah.
And how much payload we can take, and what can we do with that.
Right.
And so it looks to me like if we were to do this, I have these 3 tables here.
Okay.
I can, with 4 flights, and in this case I had to do Falcon Heavy. I cannot do Falcon 9,
Sure.
but that's okay. Because by that time, we would have become almost an expert in Falcon Heavy or New Glenn type of a thing, and then joining them together in orbit
Okay. So
in
the
3-4 years.
the
or
excess
something.
delta V requirement makes it a little hard to do with
A little
Falcon
harder to
9.
do, right, yes.
Right.
It's 31,000 as opposed to 18,000.
Okay, but it
And
can be
so-
done with the Falcon Heavy.
But it can be done with Falcon Heavy, and it would reduce the payload. Now, the payload is reduced now to 8 tons if I do 4 flights and 2 of them dock. Or if I do 5 flights, 6 flights, and 3 of them dock, I can increase the payload to 16. And if I do hydrogen, I can increase the payload even more to about 50,000 pounds.
Okay.
So I can do this even for, so this, to me, this is like a railroad.
Yeah.
I can do, say, with the same method that I'm saying that we can go to the moon and establish. And while we are establishing colonies on the moon, we could be doing this at the same time, going to Mars also at the same time. So this administration, which really, we know that the administration is interested in colonies, and President Trump has several times mentioned, want to go to Mars or go to Mars. or
Sure,
something.
sure, sure.
I have this idea which can do both, and which can do both in using the same kind of a method, and not just both, but I can go anywhere else in the solar system also at the same time.
Because we have this subway diagram.
We have a subway diagram, and with the subway diagram, we can calculate. Most of the time, we probably cannot go to some place like Jupiter with very high gravity, but you certainly can go to many of these satellites,
Right.
Jovian satellites and other places. But basically, it is the railroad. It is a causeway. There are so many exits on this causeway that we can do this. It is amazing. It's quite amazing that we can do this. We can do this right now, start right now. We can do this 7 times cheaper, and it is absolutely amazing that we
Right.
can do this. So I think we should do this, is what I'm saying, that we should, actually we must do this. So,
One thing I noticed is
Mm-hmm.
that your subway diagram is actually a little bit conservative because you don't take into account the possibility of aero braking. So it may be possible to land even heavier payloads on Mars than your subway diagram would indicate.
well, that's probably true, right?
Yeah.
Yes, yes, right, yeah.
Yeah.
But then, we have to worry about heating and other things also at the same time. So there will be some increase in dry weight because of that.
Yeah, so it'd be more development
More
costs there.
development costs
Yeah.
and so. One thing I forgot to mention is that when we do this tanks as habitats, and I really want industry and government to be in complete full partnership here, right?
Right.
So Bigelow Corporation has Bigelow Aerospace has these inflatable habitats.
Right.
They can go inside the tanks. and we can do this inside the tank.
Right.
We can put them inside the tank and they become habitable, whether they are on the surface or they are in the lava tube, wherever they may be.
Now, Bigelow, if I recall, has had inflatable, I guess, proof
Yes.
of concept devices in orbit for many years.
Yes, for many
So
years,
we-
and right, yes.
We have an idea of how well they age.
That's
and,
right, yeah.
Right.
So, and in this case, they'll be inside a tank, so we have a pretty good protection against them, but they'll just make it more comfortable for people to live in. So, this is the idea. I mean, I think that this is the cheapest, 7 times less expensive than SLS. And I think that even BFR is not needed. The whatever we have
Big Falcon. Yeah.
is just enough. Falcon Heavy. We can start this tomorrow with Falcon 9. And I think there should be a partnership between all of those combined together, and it is something that we can do. And it does not, I mean, all this time, the people interested in going to Moon and Mars have been sort of at each other's
Yeah,
throats,
it's
so
always
to
been
speak.
an either-or
Either
kind
or
of
or
debate,
something.
but
It's not either or.
Yes, that's
This,
right.
with this method, we can do both. It applies to both.
Yeah.
It is amazing. It's just, it's almost, a ideal situation or ideal solution for being able to do this, and it's a lot cheaper.
So the subway diagram, I read the fine print. The numbers assume Hohmann-Bahn, the Hohmann transfer orbits.
Right.
So there, of course, you have to wait for planets to align. So there's a periodic schedule. So we could actually fly these on a routine schedule whenever the planets align, which is almost every year.
Yeah, all the numbers in space, the subway diagrams are not necessarily Hohmann transfer. No.
Yeah.
They are not all Hohmann transfer, but some are.
Yeah. All right. Well, thank you so much. This is an exciting development. It could recatalyze our interest in space, especially with the young generation. All right.
Yes, right. Yeah, we can do that. Thank you.
Thank you so much for joining us here at Around Space. This was Dr. Ajay Kothari, who's a rocket scientist and founder of his own company, Astrox. Thank you for joining us, and see you next time.
Thank you, Ken.